Hello, is Mr. Ishank?
Yes, sir. Good morning.
Okay. So I will start taking class. Saksham 2K20A470.
Yes, sir.
What has been taught in the previous class?
So we have done Lorentz transformation of position and time.
Okay. Fine. So I will be doing waves. There was some problem in a length contraction. So time dilation, length contraction, both I will be deriving in this class, as well as the velocity transformation. That is, what will be the relative velocity transformation using the Lorentz transformation. So these are the subject matter for today's class. Is my screen is visible?
Yes, sir.
Yes, sir.
Okay. This we have done yesterday. Okay. This we have done yesterday using the Lorentz transformation. The notes will be given to you today. So we have done the modified Galilean transformation, that is Lorentz transformation of position, as well as inverse transformation of Lorentz transformation of position. Okay. Now Lorentz transformation of time. So this also we have done yesterday. Okay. So all these, like time will be this. If the v is the velocity of the reference of the frame, that is s dash, if they are moving, so t dash will be recorded like this and t will be recorded like this. That is inverse Lorentz transformation. This we have done. What we have used, the gamma square is equal to 1 minus v square by c square. Here also you check it, this will go to here and minus 1, so it will be cancelled. So it will be there 1 by v square by c square into x and into 1 this gamma square. So it can come out. Now Lorentz transformation, that is length contraction and Lorentz Fitzgerald contraction. Let's take that there are two axes, one each S frame of reference, this is S dash frame of reference. At t is equal to 0, they were coincident. And in this frame, there is a one stick. Okay, so a stick's coordinate, a person like a observer O dash, he will measure its length x2 dash minus x1 dash. Okay, and while this person will be measuring from the other frame of reference, x2 minus x1. As I have defined this is the mistake I was doing in the previous nomenclature, that x2 dash minus x1 dash, that is in the frame in which it is moving. If a person, that is O dash, is in the same frame, he is measuring its length, so that length will be proper length. And contracted length will be recorded by a stationary person. That is person O from the other frame of reference. So how much that contracted length? It will be x2 minus x1 with respect to this coordinate axis. So it will go up to here and then minus it here. So that is their x2 and x1 for this person. The frame is moving along the x-axis. So that length will be x2 minus x1. Now using Lorentz transformation, we have derived this x2 dash is equal to x2 minus vt. Here also you can derive it, like x2 will be what? From this place to this place. isn't it? Up to this it will be there. And then minus Vt will be x2 dash. And this is a correction factor we have taken using the Lorentz transformation. Or as well as because the laws of the physics should remain same, so we have taken this correction factor. And x1 dash will be this quantity. Okay. So now L0, that is when the person who is in the same frame of reference is measuring, isn't it? So that is the prime length. So actually it is L0 length, but a person from the stationary frame of reference, it will not appear L0, it will appear as a L. Okay, so x2 minus x1 is L. So this is the L is a length measured by O, observer O. Okay, so that will be appearing to be a bit less. Of course, it will depend with the correction factor, that is square root of 1 minus V square by C square. So we write L is equal to L0 into V minus square, or in this manner. So this is the original length and this is the contracted length. Okay, that is contracted length means from other frame of reference you are measuring. So what we had concluded, length of a moving rod with a velocity relative to the observer is contracted by a factor 1 minus square root 1 minus V square by C square in the direction of motion, and that contraction is called Lorentz-Fitzgerald contractions. When V is very, very less than C, L is almost equal to L0. When V is high but less than C, L will be less than L0. And when V is equal to C, then L will be 0. When V is greater than C, L will be imaginary. This cannot be true because there is a certain length, so it can't be 0, isn't it? So V cannot be equal to C or greater than C. So contraction along the direction of motion remains unchanged in the other direction. Is my voice clear?
सर एक स्टूडेंट एंट्री मांग रहा है।
एंट्री तो दे देंगे बट हमारा क्वेश्चन का भी जवाब देना होगा।
Yes, sir.
यस सर।
Okay, and also you should get entry now using your official email ID.
सर उस आईडी में कोई प्रॉब्लम आ रही है।
प्रॉब्लम आ रही है तो उसको सुलझाने के लिए तुम जिन्होंने मेल आईडी दिया है उनको बताओ, ठीक है? You got my point?
ओके सर।
उनको बता के इसको सुधारो। बट ये समझ में आ गया लेंथ कॉन्ट्रैक्शन?
Yes, sir.
I hope there should not be any doubt. That doubt yesterday I had done a mistake that हम इसमें भी ले लिए थे और इसमें भी ले लिए थे, वो करने से दिक्कत हो रहा था. Although I could have corrected there, but I thought there is no point because I was following one book. So following book is also sometimes not correct. You have to apply your own judgment. So this is better one. Suppose मान लो इसमें एक स्केल रहता जो 1 मीटर का स्केल है, we call it a meter stick. तो वो 1 मीटर जो इस ऑब्जर्वर है उसको लगेगा, इसको नहीं लगेगा, वो लगेगा कुछ 90 सेंटीमीटर है या 95 सेंटीमीटर है, डिपेंडिंग अपॉन दिस v वेलोसिटी. ओके, दिस यू मस्ट हैव ऑब्जर्व्ड बाय वाचिंग द फ्लाइट. वो देखोगे कि तुमको उसकी लेंथ तो कम लगती है, विड्थ उतना कम नहीं लगती है ना. सो ये उसी डायरेक्शन में वर्क करेगा, ठीक है. So now we call that Lorentz transformation of space and time. So space and time, it will be like this: x dash is x minus vt. Galilean transformation में क्या होगा, ये factor नहीं था. Okay, and this factor is not required if someone is moving with a very, very low velocity compared to the c. I mean, the effect will be very negligible. But when the velocity is high, we can have a high velocity, like if an electron is coming from a metal, nuclear particle is getting disintegrated, or if we in future we are able to make a spacecraft which has a very high velocity. So this is the Lorentz transformation of space and time will also be like this. So inverse Lorentz transformation of space and time will be this. Here you note that T dash was this much. So T is equal to this much. Okay. That also, how you will be deriving that? You can derive this formula also by taking x is equal to, not x dash is equal to. Okay. One can come. So I believe it is clear up to this point. Hello. Very slowly you are saying. Now coming back to the time dilation, this I have already derived the formula, but I will be deriving at this point also using the Lorentz transformation. जो previous derivation था without using the Lorentz transformation, similar to the one it is given in the book. Okay, so time intervals are affected by relative motion. That is the main point. So we can write like something is happening in a moving frame of reference, and that event is recorded as a T2 dash minus T1 dash. Something has happened that is called T0, that is proper time observed by O dash. But same event will be observed differently by a person who is in a S frame of reference, or an observer is O from the another coordinate. Okay. So now T1 is equal to, okay. So I have used this inverse Lorentz transformation. So here it is just in general, T is equal to this quantity. So T1 will be T1 dash plus Vx dash by C square. 1 minus, and T2 will be this quantity. Is it clear? Hello?
Yes, sir.
I have used this formulas. Okay. So T2 minus T1 is the interval, that is something is recorded. So T2 minus T1 will be T2 minus T1 divided by 1 minus V square by C square. And this is the proper time. That is proper time, and that event is measured in the same frame of reference taking T0. So this is the formula. So what is happening? A person who is observing that interval from a stationary frame of reference, he is finding the time is elongated. Okay, this you can also write that because it is an interval. So we can write a delta t is equal to delta t0 1 minus v square by c square. Okay. So interval will be elongated if measured from the stationary frame of observer or O. It is called time dilation. Okay, so this is the formula for time dilation. Should I go ahead?
Yes, sir.
You have had no doubt on these formulas. So we have what we have done. We have seen the using Lorentz transformation. What we have done is we have derived the formula for Lorentz space and time distribution. Using the same, we have derived the length contraction formula as well as a time dilation formula. Now let me come to the addition of velocities, how we will be doing. And we will be using Lorentz transformation, and we will show here that C plus C will become C. Okay, C plus something will become C. So let's consider two frame of reference which I have always been considering, S and S dash. S dash is moving with a velocity v relative to S along the x direction. Okay. So let us suppose body moves dx distance in time dt in system S, that is in S frame of reference. So dx dash movement is there, the body's movement in time dt dash in S dash frame of reference, and dx distance in dt time in S frame of reference. So now if we have to measure the velocity, dx by dt will be u. Okay, the velocity from the stationary frame of reference. This is the velocity in the moving frame of reference. Now what we are doing, now we are using Lorentz transformation of equation. X, which we know that X is equal to X dash plus Vt dash. Is it clear? This will be X dash plus Vt dash, because this coordinate we are taking from the stationary frame of reference, and this is from the moving frame of reference, this one. And similarly, T will be T dash plus Vx dash by C square. From where we have taken this? We have taken it from here, that inverse Lorentz transformation for the time. Is it okay? Hello?
Yes, sir.
So what I have done is time is equal to this. So I am using these two quantity now. So if I differentiate this, what is differentiable? The x dash is differentiable and t dash is differentiable. This is a general formula. So dx is equal to dx dash plus v dt dash and 1 minus v square. And similarly here dt will be this variable and the x dash variable, dx dash. 1 minus v square by c square. Okay. And from here I want to find out dx by dt. Dx by dt. Okay. What is the dx by dt? Dx by, let's say that in S dash frame of reference, let's say in a train, I'm giving you an example. In a train which is moving with a v velocity relative to you, you are on the platform, and in the train your friend is also moving, isn't it? So your friend's velocity is measured on the train is u dash, and train is moving with a v velocity. Okay, so you will be recording its velocity of your friend as a u dash plus v using the Galilean transformation. But using the Lorentz transformation, the velocity will be like this, u dash plus v, and then this quantity will also be coming, because these will be cancelled, but in the below it is like this. So here we have divided this by dt dash, dt dash, dt dash, dt dash. We have divided in this expression. So this one will be dx dash by dt dash plus v, and here also. So the formula, that is, you will be recording the velocity of your friend who is moving with a u dash velocity in the train, and u dash is measured by some person on the train, and the train is moving with a v velocity, then you will be recording his velocity as this much. Okay, u dash plus v divided by 1 plus u dash v by c square. That is the relativistic law of addition of velocity. Whereas in a classical mechanics or in a Galilean transformation, it could have been only u dash plus v. Is it clear?
Yes, sir.
So what, I have not done anything. Now you see this, when u dash and v are smaller compared to c. U dash and v are smaller compared to c. Just a minute. U dash and v dash are much smaller, so their product will be also smaller compared to the c. So like here u dash v by c square will be a small value. Okay, so we can neglect, and therefore u will be u dash plus v. That is a classical formulation. That is Galilean transformation. So something, if you are, I am always emphasizing, if you are developing something new, it should resemble to the original theory. Then only your theory will be regarded. Okay, that will be considered, yes, you have developed some new thing. I mean, it should not, in certain cases, it should satisfy the old one also. Now let's say when u dash or v is equal to c. Okay, is equal to c, any one of them. Let's say the train is moving with a v velocity and your friend is running there with a c velocity. It is impossible, today's knowledge, but just for an assumption, then what will happen? Classically, you will have a c plus v velocity. Okay. Now what is happening here, if you substitute any one of as equal to c, it will not be greater than, like if I have substituted u dash is equal to c, that is your friend is running, say your friend is nothing but a photon, is your friend. So photon is there, light is moving with the c velocity. So I should have recorded from the platform that is velocity is c plus v, which is violating the Einstein's postulates. Einstein's postulate violating means it should not be greater than this c. So using this Lorentz transformation of addition of velocity formula, if you substitute u dash is equal to c, yes, here v c square. So what will be happening? This will be this quantity. So this will be cancelled out. It will become equal to c. Okay. Similarly, if let's say u dash is your friend is also running with a c velocity and train is running with a c velocity in the same direction, then ideally we should have recorded as a c plus c, 2c, if it is a Galilean transformation. But actually it is not. You can substitute that and you will find that will be equal to c. U dash also I have substituted c, v also I have substituted c, and both you substitute, it is coming to the u is equal to c. That is, you will be recording its velocity as a c only, not 2c. Is it interesting?
Yes, sir.
And this is what I have said that in 2-3 class back, that after 2-3 class I will be proving that c plus c, which you could have recorded as using a Galilean transformation as a 2c, but using the Lorentz transformation, we are proving that no, it will be the velocity will be recorded as a c. Like some object is there. Let's say I will give you some numerical problem. It is moving along the positive x direction, and in the same line along the negative x direction also another object is moving. Okay, so you are moving in the same direction where the other party is approaching. So ideally you could have recorded more velocity, but you will not be recording more velocity. Like say if person who is moving along the positive x side is a 0.8 c, and person who is moving on the same line with a 0.5 c on the same direction, then using classical mechanics, your velocity of the other person who is moving along your direction, you should have a 1.3 c, but it will not be. Using our Lorentz transformation of velocity or laws of the addition of velocities, we can prove that I will be recording its velocity, the relative velocity recorded will be equal to c. Okay, so till now what I have done it, I started with the Lorentz transformation. We have done it Lorentz transformation of a position as well as a time. How the time changes, that also formula we have derived. Okay, and then length contraction, time dilation, velocity addition, that we have done it. So now let's do some numerical problem. An event occurs at x is equal to 100 meter, y is equal to 10 meter, and z is equal to 5 meter. And that event has an interval t is equal to 1 into 10 to the power minus 4 seconds. That is, that event takes that time. Okay, in frame S, find the coordinate of this event in a frame S dash. which is moving with a velocity 2.7 into 10 to the power 8 meter per second with respect to the frame S. Okay, along the common x dash axis using Galilean transformation as well as a Lorentz transformation. Okay, so you people try this. 2 minutes time. This is the question. Okay. Galilean transformation. If you are using, then what will be the value of x dash? What will be the value of y dash? What will be value of z dash? And what will be the value of t dash? In Galilean transformation, t is equal to t dash. There is no movement along the y and z, so y dash will be equal to y, z will be equal to z dash. Our z dash will be equal to z. That is the same 10 meter, 5 meter. Only x we have to see. Okay. So what you will be using? That is x dash is equal to. क्या लिखोगे? Roll number 10. Hello? Hello? Is this question is clear? Hello?
Yes, sir.
Okay, so thus you see that x dash is equal to x minus vt, isn't it? So why this will be in the Galilean transformation. So x is what? 100 meter. V is this 2.7 into 10 to the power 8. T is this. So it will be coming minus 269. There is 26,900 meter. Okay, it can be minus, just to check my diagram. Any diagram. Like for example, this is moving. So it will be appearing this side. Okay, x is equal to 100 meter here. And it has moved with a very high velocity. So maybe it has come to this point. So for this coordinate, it will be minus x dash it is happening. Okay. So this much. Y and y, thus the coordinate in frame S dash will be this much. And here t is equal to t dash. So very simple. Now using the Lorentz transformation, you derive it. Lorentz transformation x dash will be x minus vt. Is it clear or not? You just assume the two frame of reference. Moving frame of reference, if you take a x dash from the other frame of reference, it will be larger value x minus vt will be there. And then you are using this formula. Similarly, t dash, you are using this formula. T minus Vx by c square. From how we have derived this? We have derived this formula. Where is that? Where is that time dilation? Okay, we have derived the here. Sorry, T is equal. Yeah, this formula. Okay. Transformation of time. So that is what from there we are using in this numerical problem. Yeah. So if you substitute, it will be coming this many meter. Okay, I hope I have done correctly, but this is the meter. Similarly, T dash will be, that interval will be recorded 2 into something into 10 to the power minus 4 second. Okay. So x dash is this, y dash, and t dash is this much. Now use Lorentz transformation. This is the problem number one. The another problem is that use Lorentz transformation to show that this expression x square plus y square plus z square minus c square t square is equal to this quantity. Or sometimes this same problem can come that prove that x square plus y square plus z square minus c square t square is invariant under Lorentz transformation. That is, the expression will remain same if we are using it in from the another frame of reference. Okay, so how to use that so that it is like this. That is, this is given that it is in invariant. So I want that this is in S frame of reference. In S dash frame of reference, the coordinate will be x dash, y dash, z dash, and t dash. So what will be x dash? Hello? X dash will be this quantity. Y dash will be this because there is no movement. T dash is equal to this much. So what we are doing, we are using x square plus y square plus x dash square plus y dash square plus z dash square minus c square t. Okay. So what is x dash? In place of x dash, you will be using this Lorentz transformation. Okay. Here. Now, again, same thing I am using here. So you just solve this equation. It will be coming like this. X minus vt square will be this whole square. I have done it. And here also some whole square I have done it. Then what will happen? Plus y square z square. Okay. So if you derive it, there will be something common from here, 1 minus v square by c square, and from here also, just to check it. I have done it very carefully. So 1 minus v square by c square will come in. For example, x square, you take it. So it will be 1 minus. And another x square will be coming from this one, where x square c4, but it will be multiplied by c square. So x square will have a v square by c square. And similarly, if you are taking c square t square here, so it will be 1. And this c square and c square will be multiplied, then it will be cancelled, and minus minus will be plus. So this term and this term will be cancelled. V square t square will be here because c square you are multiplying, then it is a cancel, so minus v square. So I have not done anything wrong. And then you take this common, so this term will be cancelled. And so it will become x square minus c square t square plus y square plus z square. And that is equal to this. That means this is an invariant. This shows that the quantity x square plus y square plus z square minus c square t square is the same in both frames of reference. So this is invariant under Lorentz transformation. That is the problem number 2. This is just a typical problem I am doing. It is not necessarily that the same thing will be coming in the examination. But in examination, there will be a numerical problem, and the solutions, even if it is in an objective type of examination, multiple choice, will give a numerical problem, and the choice will be there, so you will be taking it. But for that choice, you have to solve, and then you will be keeping it. Now let's go with another problem. An electron is moving with a speed of 0.85 c in a direction opposite to that of a moving photon. that of a, like, and you take an say suppose you make a S frame of reference. So along the X direction, electron is moving with a 0.85 c. Opposite to that of a photon movement. Photon movement means its velocity is a c, even if it is not written. Okay. So calculate the relative velocity with respect to the photon. So since photon is approaching, okay, so had it been be a classical physics or Galilean transformation, we could have said that it will be coming 1.85 c will be the velocity. But it cannot be more than the c velocity, and therefore using the Lorentz transformation, laws of addition of velocity, we will have this formula. U dash is equal to u minus v. What is there? Here u dash is electrons movement 0.85 c. Sorry, how much is the relative velocity? Electrons motion is 0.85 c. And v is what? V is equal to c minus c. It is moving along the same direction. So if you substitute it, it will be this quantity. So u dash will be equal to c. That means it is not exceeding the c. So the relative motion will be equal to the c velocity. That much will be experienced with respect to the photon. Is it clear? Hello?
Yes, sir.
So there will be a
Yes, sir.
infinite number of numerical problems based on this. Okay, based on these things. So I will be sending you these notes. Okay. And you must solve some of the, do from your book or from other sources also. Numerical problem, try to understand, have a derivation. Somewhere the derivation I have done it in my own ways, which is not given in the book. And therefore, you have to understand how the derivation is done. Okay. I can give you another numerical problem also. I was fast enough. Okay. Hello. Hello. Are you people are listening?
Yes, sir.
Yes, sir.
Okay. Then you write a numerical problem. I am dictating from here. You can write a cube. I can put it into the chat box. So I am stop sharing. Okay. So I am writing a cube. A cube has a volume as a volume of 1000 cubic centimeter. Okay, find the volume as determined by an observer O dash who moves at a velocity of 0.8 c relative to the cube in a direction parallel to one edge. Parallel, I have put a wrong spelling. I will be giving you parallel to one edge. I am repeating the to one edge. Question is this: a cube has a volume of 1000 cubic centimeter. Find the volume as determined by the observer O dash who moves at a velocity 0.8 c relative to the cube in a direction parallel to one edge. Suppose you have a two frame of reference, S and S dash frame of reference. In S frame of reference, a cube is there, its volume is recorded 100 cubic centimeter. That is, it is of a 10 centimeter each side. And from S dash, what is happening? That is, an observer is there who is measuring, but that observer is moving with a 0.8 c velocity. So you can say there is a relative motion of 0.8 c velocity along in one edge. Let's say along the x-axis side edge is there. So what will be happening, since there is a relative motion, so length will be appearing to be contracted. Okay, length will be appearing to contracted. So one side will be having not the 10 centimeters, some less value. And therefore the volume appeared will be less. That is something will be the less. It will be around 600 cubic centimeter. So what you will be using, you can use the formula here. It is moving along the, okay, I'm also shared this, okay, the question. Is the question is there on your chat box?
Yes, sir.
Okay, and this I
Yes,
have.
sir.
So you got what will happen? Suppose along the x-axis, length will be appearing contracted. So it will be L dash will be L into 1 minus V square by C square. L is what? It is a 10 centimeter. That is, you can say, proper length. And if there is a relative motion, then 1 by V square by C square will be there. So if you calculate it, it will be coming 0.6 meter. Okay. And its volume, if you calculate it, then it will be coming 600 centimeter. You got the point? So volume will be appearing contracted. Okay, like a ellipse will be there. Say some elliptical type of a shape is there. Elliptical type of a shape. So major axis will look you as a minor axis and minor axis will look you as a major axis. Type of a things. I mean, its volume will be not the same in the moving frame of reference. I mean, if there is a relative velocity between them. So there will be, certainly there will be many such type of, I have just selected 3-4 numerical problems so that you can have an idea and the feeling of the impact of the theory of relativity. Okay, the special theory of relativity. So in summary, what I have taught in this class each, I continued with Lorentz transformation derivation, which we have done it in the previous class. Okay, the important point is to find out the value of the k. Okay, that is the factor that 1 by 1 minus v square by c square comes. I call it as a gamma. And then we do that. Modifying Galilean transformation means giving the Lorentz transformation of position. Then we have derived the formula for Lorentz transformation of time. Okay, so this derivation is there. You are supposed to do it. If there is a descriptive examination, this may come to there. So these formulas will be there. So kindly remember these formulas, some of them also, for solving the numerical problem. Okay. So I am not saying you can always derive this formula in a minute also. So some understanding and some effort is required. Like if I am sending you the notes, or if you have attended the class and then you don't do it anything, then maybe it will be a bit difficult. So my suggestion is there that even if the notes is sent to you, you write in your notebook how these have been done it. Okay. Then we have come for the length contraction. We have derived the formula, some special cases we have done it. And related to that, the numerical problem we are doing that. That cube will not be a cube. That is a 1000 cubic centimeter of an object will be looking me as a 600 cubic centimeter. Then this is in general called the Lorentz transformation of space and time. And using Lorentz transformation, this is the new thing which we have done it today, is a time dilation formula. This I have derived earlier also. Okay, you can use any of the formula, I don't mind. I mean method of derivation, but you should use appropriate formula. Then we have done addition of velocities. Okay. And finally, u will be u dash plus v divided by 1 plus u dash v by c square. What is u dash? What is v? V is the relative motion of the frame of observation. And u dash is the velocity of the object which is moving on a moving frame of reference with velocity v. So it is recorded u dash in that frame of reference. So to us, it will look like this. Actual one will be this one, and this is derived. So this follows the Einstein's assumption that the anything which will be moving will not be greater than the c. So a new transformation of equation was there. Okay, and then it's a special case. C plus c will become c. C plus something will also become c. Okay, I find it is very interesting derivation. And then we have done 2-3 numerical problems, rather 4 numerical problems. And that's complete my class, today's class. Have you followed, all of you?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
And somebody tell me that I am not followed. My screen is visible?
Yes, sir.
Oh, so there was no screen. There is no screen. Okay. I was summarizing by looking there, but somehow, okay. numerical problem.
क्लास में ही है सर भाई अभी।
कोई रिकॉर्ड कर रहा है क्या ये क्लास?
प्लीज शांति बनाए रखिए, सर आते ही होंगे।
सर मीटिंग में है।
Mute yourself.
सर आप म्यूट हैं। सर योर माइक इज म्यूटेड।
Okay, now it is clear.
सर
Yes, sir.
कैन यू रिपीट व्हाट यू सेड? योर माइक वाज म्यूटेड।
Acha. Was it for a longer time?
नो सर, ओनली अ मिनट।
Only a minute. It was muted. Okay. So I have given you a one numerical problem on a chat box also. Okay. Emphasizing that cube is no longer cube for the other observer of reference. So Lorentz transformation of space and time dilation, length contraction, velocity addition. These are the main features. Now what I will be doing in the next class, I will be trying to derive the formula for the E is equal to mc square, how it is coming. That I will be doing. Achho, no, I have to do the mass conversion formula also. Okay. So relativistic mass, that I will be doing in the next class. Okay. So this is all about today's class. If you have any problem, in a last 1 minute, somebody can ask me one question. Hello?
No, sir. Thank you.
नो
There
सर।
is no question. Sankalp forgot. No, what is that? Sankalp Gehlot. You have any question?
नो सर।
Have you followed what I have taught?
यस सर।
Okay. What is Mr. Ayush Anand?
Yes, sir.
Things were clear?
Yes, sir.
Okay, then do it. My class is over. Thank you very much.
Thank you, sir.
Bye, sir.
थैंक यू।
Hello, beta, am I audible?
Yes,
Hello.
ma'am.
Yes, ma'am.
Yes, ma'am.
So, see, as the beginning of the class and end of the class, I will be taking the screenshot 2 times. Okay. So that's how I record the attendance. And be careful and you attend the class. Fine. So far, 64 students have joined. So anyway, I don't wait for everyone. Okay, I will keep allowing them in between. I'm starting the class. So, hello, hello, beta.
Yes, ma'am.
Hello.
Yes, ma'am.
Yes. So far we have seen titiometric analysis, so the basic definitions, how many types of titrations are there, and acid-base indicators, and acid-base indicators. How much? Why we are? How the indicators are changing the color? Okay. What are the theories associated with these indicators, and how they change the color, and all these things we have studied in detail. Okay. So today's class. Just a minute, I'll allow him. See, I'll keep late entries, I will keep allowing them, and after 5 or 10 minutes only. Okay, so all the here, if you see that these slides, only the structure of phenolphthalein, structure of acid-base indicators are shown here. This is the structure of phenolphthalein. Already we have seen. This is benzonoid structure. Okay. The second thing is this is see the different pH range. See, when it is colorless, this is a benzonoid form. Okay, when it is colored, the pink color, it is quinonoid form. Okay, the structure changes from acidic medium to the alkaline medium. When it is acidic, it is colorless. When it is base, it is colored because of this structural change. Okay, so here the table has shown that different type of structures of a phenolphthalein at different pH range. This is the below pH 1, that is around 1. Okay, this is 0 to 8.2. Okay, this is the structure, and 8.2 to 10, this is the structure. Above 10, this is the structure. Okay, the form it is if you see the below 0, that minus one pH scale is not there. Okay, you can say that it is around 0. Okay, the structure of phenolphthalein, this one, it has a 3 H plus ions. Okay, when you see this, the color is the orange color. 0 to 8.2, the colorless, and in the basic medium, it changes to pink color. And again, above 10, it changes to colorless because of this structural changes. Okay, so same way here it is shown in different way. Okay, how color can change, resonance can happen. You can all go through this. And coming to the phenolphthalein, and the phenolphthalein, if you see the phenolphthalein here again the structural change is there. The structural change in the basic medium, it is yellow in color. Okay, this is when it is coming to the acidic medium. Okay, acidic medium, it is red in color. Okay, due to the structural change from this is benzonoid to quinonoid. Okay, so these are all extra information for you. Okay, let him follow who is waiting. Okay, so far, is there any doubt, beta? Hello.
No, ma'am.
No, ma'am.
Okay. So the
No,
next
ma'am.
coming to the different types of acid-base titration. The one is a strong acid versus strong base. The strong acid example is hydrochloric acid. The strong base is sodium hydroxide. Okay. The weak acid versus strong base. Weak acid is the acetic acid, organic acid. Mostly all organic acids are weak acids. Strong base sodium hydroxide. Okay, here the strong acid, hydrochloric acid. The weak base, coming to the weak base, it is ammonium hydroxide. Ammonium hydroxide is a weak base. The weak acid versus weak base, weak acid is acetic acid, weak base is ammonium hydroxide. Okay, these are all the 4 types of titrations we are going to see. How it is, so while you are doing the titration, you are adding sodium hydroxide to HCl. Okay, hydrochloric acid. Hydrochloric acid solution, you will be taking conical flask, sodium hydroxide in the burette. Okay, when you start adding the drop wise, what will happen? Hydrochloric you have taken in one flask, you are keep on adding. When you add, what will happen? The acid here, the pH of the acid slowly it will rise. Okay, slowly it will rise. When equal point, there will be sudden jump. So you know that when the neutralization reactions are happening from NaOH to HCl, completely the pH will become 7. When you are adding the extra drop, so when you are adding the extra drop of now it is clear. Hello.
Yes, ma'am.
Hello. Okay. So when you are adding extra drop of sodium hydroxide, what will happen? The extra drop suddenly raises the pH. Okay, that is called equivalence point. You have seen. We have see when completely the reaction happens from sodium hydroxide and hydrochloric acid. Complete reaction is completing. The pH is 7. When you are adding extra drop, suddenly the pH change will be there. Okay, so the pH, this is the region where the sudden pH jump from this is the point, from this point the pH jumps. Okay, that the point is the end point. This is the end point, this is the equivalence point. Equivalence point you cannot visualize, end point by adding indicator you can visualize. So is it clear? Hello.
Yes, ma'am.
Yes, ma'am.
Okay, suppose if you add ulta, okay, that means acid in the burette in conical flask base, what will happen? The pH will start decreasing. Okay, the pH will start decreasing like this, like this, like this, and the sudden jump will be in the same region. Finally, it will become acidic. Right? Hello. So here the methyl orange from yes, okay. So the next you can see that here volume of acid added. Volume of acid added. So when you are adding acid, the pH from the alkaline it slowly decreases, and then suddenly the pH will decrease like anything. Okay, it will become acidic. Okay, so this is the equivalence point. This is the end point. When you are adding base to the when you are adding acid to the base. Okay,
मैम वॉइस
basic
लैग कर रही है
pH is
आपकी
around. बेटर थोड़ा से एडजस्ट करना पड़ेगा बिकॉज एवरीवन हैज द इंटरनेट प्रॉब्लम ओके सो आई विल रिपीट इट ओके फाइन आई विल रिपीट
मैम हमने अनऑफिशियल आईडी से ज्वाइन कर रखा है तो अटेंडेंस लग जाएगी ना
आई कुड नॉट लिसन टू यू
मैम वी हैव जॉइंड यूजिंग आवर अनऑफिशियल आईडीज नॉट आवर ऑफिशियल आईडी सो इज इट will you mark the attendance
type the message so clear now hello
मैम आपकी वॉइस बहुत लैग हो रही है
मैम काफी लैग हो रही है आवाज आपकी
आवाज आ ही नहीं रही है अब तो
मैम समझ भी नहीं आ रहा क्या बोल रहे हैं
but अपना internet also you have to check okay anyway I am recording everything my voice okay I will be posting to you recorded video
मैम किसी को भी आवाज नहीं आ रही है बहुत ज्यादा लैग हो रही है
मैम नहीं आ रही सही
नहीं आ रही मैम बहुत ज्यादा लैग हो रही है
मैम नहीं आ रही
नहीं आ रही है आपकी आवाज नहीं आ
रही listen the only group you are complaining about the internet is your group the group A8 also I am teaching absolutely there is no problem okay so what I will do is I am recording my speech okay I will put it in the Google Classroom you can listen to my talk okay in that way we can solve it fine
yes ma'am
okay wherever there is a problem there should be a solution fine see, we are recording if you see that every talk is recorded here okay I will put this recorded message to Google Classroom then I want to open and listen to my lecture is clear fine Ishant Sir is around
yes ma'am
Ishant
yes ma'am
is it what I'm saying? Okay
your voice is lagging
so if any connection is bad my connection is bad the recording is going on here so I'm recording I'll bring it into the your Google Classroom so there should not any complaint my voice will be clear in that
sure
okay this is the one the pH when you add base when you add acid to the base your pH will decrease when the equivalent at exactly at equivalence point pH becomes after the equivalent point it becomes acidic okay so this is how things happen so in the case of weak acid, acetic acid. So, wait a minute, I'll come to my slide. So weak acid, this is actually acetic acid, it's not oxalic acid. And strong base, sodium hydroxide. Here there is some mistake. I will correct it. This is not oxalic acid. This is acetic acid. It's vertical. So the same way here again, the pH decrease will be there. Okay, if you add acetic acid to sodium hydroxide. But if you see this portion, this portion is shorter. Okay, this portion is shorter when we compare to strong acid and strong base. Because since it is a strong base here, weak acid, it neutralizes very fast. Fine. So, this is approximate pH range is 7 to 11. This vertical region is 7 to 11. Whereas here, if you see that 4 to 6.5, this is actually one, and the broad pH range 4 to 10. Okay, 4 to 10. The sudden jump is from this is 4 and this is 10. Is it clear? Hello.
Yes, ma'am.
Here you see that since it is a weak acid, strong base, and it is from the pH range. pH range is 7 to 11. Okay, this is shorter. Okay. So the next one, this is again the strong acid. Strong acid here is either hydrochloric acid or H2SO4 or nitric acid. It's a weak base, ammonium hydroxide. Same way here, this is also shorter, but the range of the sudden jump is from 4 to 7. When you see this 4 to 7, you have to choose your indicator. Depending on this range only, you are choosing the indicator. Here, what will be the correct indicator? If you see this, this is this range. The strong acid, strong base. This region is 4 to 10. Okay. So the indicators are phenolphthalein, and there are 2 indicators available in the market. Okay, so the phenolphthalein, it changes color 8.3 to 10.5. The methyl red, methyl orange changes the color. Methyl red changes color 4.4 to 6.5, and methyl orange 3.2 to 4.5. Whatever the indicator you are choosing here, it should fit into this region. If you see that phenolphthalein can be used, another indicator is methyl orange. Methyl orange is within the range. Okay, this is 3.5. Actually speaking, 3.5, 0.5 is not a problem. So phenolphthalein and methyl orange can be used in the case of the strong acid and strong base. This is how we choose the indicator for a particular type of acid base reaction. Is it fine? Hello.
Yes, ma'am.
In this case, this is is there Dhruv around? Hello. Beta Dhruv is there?
Hello. सारे वर्ड लैग हो रहे हैं मैडम, कुछ समझ नहीं आ रहा.
यस मैम, बिल्कुल समझ नहीं आ रहा.
नहीं, already I have explained you. Okay, you try to explain me strong acid.
मैम एक वर्ड भी नहीं आ रही आपकी आवाज.
That is not. I don't agree with that. I have a recorded. Every speech is getting.
मैम हम आपको रिकॉर्डिंग भी भेज सकते हैं, स्क्रीन रिकॉर्ड करके.
मैम सबको ही प्रॉब्लम है.
आज शायद नेटवर्क इशू है मैडम आपके एरिया में।
Ma'am,
But people have to understand.
ma'am, on Monday your voice was clear and it wasn't lagging. Ma'am, I think there's a network issue in your area today.
मैम यूट्यूब चला के देख लो, वो भी नहीं चलेगा आपका।
मैम तो लीव कर गए शायद भाई।
लीव कर दे अंधी।
भाई कुछ समझ थोड़ी आ रहा है, बिल्कुल ही आवाज एकदम नहीं आ रही।
एक वर्ड बस समझ में आ रहा है, शुरुआत हो रही है,
हाँ तो
उसके
भाई
खत्म हो
एक
जा रहा
वर्ड
है।
तो समझ आए कुछ
मेरा
नहीं।
मम्मी डांटती है, तेरी तुम झूठ बोलती हो।
हाँ भाई बीच में अटक जा रहा है आवाज।
मैम का एक वर्ड उसके बाद सारा लैग होने लग जा रहा है।
ऊपर से मैडम कह रही समझने की कोशिश करो। तो मैं कहने वाला था ना कि मैं एक काम करो, आप अपने आप को म्यूट कर लो, हम लोग खुद ही पढ़ के समझ लेंगे जो आपने जो पीडीएफ दे रखी।
ये भी ठीक है
भाई आप, हाँ कम से कम वो सवाल
मैडम
करने से
क्लास
तक।
में है।
नहीं भाई, कंट्रोल।
Hello. Am I audible now?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So, Duru, can you explain
What, madam?
how the strong acid and strong base reacts?
स्ट्रॉन्ग एसिड और स्ट्रॉन्ग बेस का समझ आया था कि वो pH 4 से लेके 10 तक एकदम सडन ड्रॉप चेंज होता है pH में। उसके बाद वो
नहीं,
स्लैग
just
हुई थी।
क्यों sudden drop क्यों होता है?
क्योंकि
Why?
वो इक्विवेलेंस पॉइंट पे जाता है ना, तो वहाँ पे कंसंट्रेशन बराबर सी हो जाती है, तो वहाँ पे पॉइंट चेंज ही होगा ना अगर किसी का ड्रॉप डालेंगे तो
So what is the
एक्स्ट्रा हो जाएगा।
difference between equivalence point and end point?
इक्विवेलेंस पॉइंट वो होती है जहाँ दोनों की कंसंट्रेशन बराबर हो जाए, और एंड पॉइंट वो होता है जहाँ हमें रिजल्ट मिले कलर चेंज।
Ma'am, we can't find the
Why the
equivalent point, ma'am, but we can find the end point.
okay, why we can find the end point?
Because of color change of indicator.
We can observe the color change.
Okay, why the indicator is changing the color?
Because the
Why
change
the
in indicator structure, cunenoid form and
Okay.
benzonoid form.
Okay,
Concentration
fine.
of
Okay, now
oxygen.
okay, good. And for presentation. But internet actually for few days it is a issue only. Okay, even though internet issues, we are recording. You should understand our whatever our class is recorded. Okay, so I will put the link to you. Okay, you can listen to that. Fine.
Okay, for today's class you put that.
Yeah, I put for every I have the record. I can put it. Okay.
Okay, ma'am.
Okay, ma'am.
Yeah. So this is in the case of acid and base. In the case of strong acid base, also this will become shorter. This ranges 7. When it's 4 to 7, which is a suitable indicator. So 4 to 7 means phenolphthalein cannot be an indicator, right? That is, phenolphthalein will come around 8.2 to 10. Okay, so methyl orange and methyl red could be a suitable indicator, right? Hello.
Yes, madam.
Yes, ma'am.
The second one, if you titrate weak acid, weak base. In the case of weak acid, weak base, क्या होगा? Because it is like a, it cannot dissociate completely. All the weak acid, it is easy to release H plus size. In the case, it will the equilibrium between associated form and dissociated. What happens?
Ma'am, your voice is breaking again.
Not audible. Not audible. I'm not audible.
Ma'am, it's not audible.
Yesterday also the connection was bad. Okay, so we have to see that. See, I will be putting the recorded message. Is it fine? Recorded message it for you, right? You can follow it and you can put the questions in the this command. Hello. Am I audible?
Now audible, madam.
Hello.
Yes, ma'am.
Am I audible or not?
मैम 1-2 सेकंड के लिए बस आवाज आ रही है सही से, फिर नहीं आ रही बिल्कुल
मैम
भी।
स्टार्टिंग वो हेलो हेलो ठीक रहता है, फिर ब्रेक होने लगती है।
या सेम।
Fine. Okay, I will explain. Okay, the connection again it went off. So Airtel connection is there. Am I audible now? Hello.
So yes sir, you are audible. Yes ma'am.
Hello.
Yes
Ma'am,
ma'am.
your
You
voice
are
is audible
audible.
only for 2 to 3 seconds. After that, we can't hear you.
So this is how the weak acid, weak base. So can you see my presentation?
No ma'am.
Yes, ma'am.
Yes
Presentation,
Yes,
can
ma'am.
you see?
Visible
Wait
now,
a minute,
ma'am.
I'll come to the slide. See, especially in the morning classes, I always have the problem, but evening classes are better. Okay.
Okay, madam. वो weak
So
acid
this
वाला
is
दोबारा
baby
explain.
structure. Right? Can you see the structure? Can you see my slide?
स्लाइड तो दिख रही है पर वॉइस ब्रेक हो रही है।
मेरी आवाज।
So
No, ma'am. मैम लेफ्ट कर दी ना?
हेलो। भाई रिकॉर्डिंग के बारे में क्या बोल रहे हैं?
मैम आ
आ
गई
गई मैडम आ गई।
Listen. See, even though today the connection is very bad, what I will do is I will record the lecture and I'll put you in the Google Classroom. Is it fine for you?
Yes, ma'am.
Attendance, ma'am.
Hello. Yes.
Yes.
Attendance screenshot मैंने ले चुका. Okay. Now it is not. Now we have another 30 minutes. And also, I want to ask you one question. Do you have any free class tomorrow in the afternoon?
Any free class?
Hello.
Yes, ma'am.
Free class. Ishant, when is that free class?
3 बजे के बाद।
I'll check.
मैम 10 to 11 और 3 to 4.
10 to 11. 10 to 11, I will take class. Okay.
Okay, ma'am.
Fine. Tomorrow,
Okay.
10 to 11, again I will take the class. And tell me anything.
आपकी वही सब ठीक है तो आप कंटिन्यू कर सकते हो।
Yeah, of course, I'm going to continue.
ओके मैम।
So can you see my slide?
Yes, ma'am.
Yes, ma'am.
Okay, when you come to the weak acid, weak base, this type of wavy graph will be there. Okay, this change, like here, there won't be short change. Okay, so in because of this, we cannot find a suitable indicator in the case of weak acid and weak base. So this weak acid, weak base titrations cannot be done in the case by titration analysis. Classical titration analysis, we cannot do this weak acid, weak base titration because there won't be any clear change in the pH. Okay, while you are adding acid to base or base to acid. Okay, is it clear to you?
Madam, why there is short change? मतलब short change क्यों है?
Short change QA because there is a weak acid and a weak base. Okay, weak acid, the dissociation of like protons, H plus ions, and the weak base, dissociation of OH minus ions, it is not so easy. It's a reversible reaction. Right? If you see that acetic acid dissociation is reversible always. It is associated form, dissociated form. So equilibrium shift from one associated to dissociated, it is not easy. That's why this is very short. Okay, this will keep on. It's like a wavy structure. Clear?
Okay, madam. Okay, clear.
Yeah. So this is how we choose the indicator. So as strong acid, strong base, the methyl orange, weak acid, strong base, others like weak acid, strong base, you can say that either it can be a phenolphthalein, and weak base and strong acid, methyl red and methyl orange, weak acid and weak base, there is no indicator. Fine? Hello?
Yes, ma'am.
Hello? So this is again, once again, we are showing here how the color is changing, and everything. See, if you see, this range is so lengthy here. In the case of strong acid, it is shorter. Here again, it is shorter. It is a wavy structure. There is no the sharp change. Okay. So if you take this acid-base titration, there is two things: alkalimetry, acidimetry. See, what is that alkalimetry? Alkalimetry is primarily a way of measuring the acid neutralizing capacity of water. Okay, this you have done the experiment. Your third experiment in the practical, you have done it. In that, alkalinity, how will you define the alkalinity? Alkalinity is primarily a way of measuring the acid neutralizing capacity of water. Okay, so the water, if you take, it should be the for water pH should be around 7. Okay, but due to the water pollution and ions present in the water, it cannot be pH 7. Okay, natural, from natural source, it can be acidic or it can be alkaline. In general, so alkalinity of water is due to hydroxide ions and carbonate ions, bicarbonate ions, and see, total alkalinity is the sum of all these three things. Is it clear? Why the acid is, water is alkaline? The alkalinity of water is due to the presence of OH minus and carbonate ions, bicarbonate ions. Better clear? Hello?
Yes, ma'am.
Hello? Okay. So the neutral is H plus OH minus ions, neutral, and so when it is slightly basic, in the carbonate ions are slightly basic, and when you see HCO3 minus and H plus, and this carbonic acid is acidic. Okay, so this is acidic, this is basic when you write the equations. Okay, so what will happen in the case of H2CO3? There are two H plus ions. Okay, so H2CO3 has a 2H plus ion, whereas this NaOH is or HCl is 1H plus ion. Okay, if you take hydrochloric acid, there is 1H plus ion. So what will happen? There are, in this case, we have to use, see here, there will be the two humps like this, two like this. If you see the two sudden changes can happen. First set will happen from NaOH, the OH will be released very easily. So that the first H plus ions will be released here. So this is due to this and the first jump. The second jump from the, if you see that second H plus ion. Okay, the second H plus ion is in the slightly basic conditions, it will go. So there is a two steps in the type of mixture. When you titrated alkaline water against hydrochloric acid, you used phenolphthalein first. Okay, the phenolphthalein will give you the end point of NaOH and as well as off of the H2CO. The second off is neutralized here. For this indicator is methyl orange. The color changes from pH acidic side pH 3.22 or 3.22 around 4.5. So you understand that why two indicators are used in the case of alkalimetry.
Yes, madam.
Hello. Okay, because of this partial dissociation. Partial dissociation is happening here. So next we are coming to the next titration, complexometric titration. What is complexometric titration? The complexometric titration means the complex formation can happen. The complex, what are complex forming elements? Metal ions, especially the metal ions with the ligands. Okay, what is type of bond is forming from metal ion to ligand? That is a coordination bond. Okay, so it is in a complexometric titration also the type of volumetric analysis. It involves the formation of complexes, strongly ionized in solution. Okay, the complex is formed by the reaction of, as I told you, the metal ion and the ligand. The ligand will give a pair of electron and it will form a coordination bond with this the metal ion. Okay, so the resulting colored complexes, or we have to identify resulting colored complexes. That is the so the color change from the uncomplexed state to the complex state. Okay, so when the metal ions are without complex, it will have a one color. After complexing, it will show the another color. Okay, this is how we have to detect the completion of complexometric titration. So so any one of you, can you explain what I explained? Complexometric titration. Hello. Hello, beta.
Yes, madam.
So can you explain what is meant by complexometric titration?
Ma'am, the change in color is obtained by the formation of a complex compound.
Very good. Then, so uncomplexed metal ion will remain, and the complex, due to the uncomplexed metal ion and complex metal ion, there is a color change. Okay, based on that we are detecting. Okay, so let me go to the presentation. Okay, so okay, so this is how the complexation is happening. That is M plus. This is a metal ion. This is a ligand Ml. Okay. For example, silver ion. Silver ion salt oxidation state is a +1, and the coordination numbers are 2. Okay. These are all you must have studied. This 2CN. This is a ligand. So electron donating group is this C. This C. So the formation, it will donate one ligand will donate a pair of electron to Ag plus. So AgCN twice. This is the complex. This will have one color and this will have another color. Okay, same way copper 2 plus. So coordination number is 4. Okay, that's why CuCN 4. This is entire the oxidation number of this entire complex is 2 minus. So these are all, we are not going into all details about it. Okay, our aim is to understand the titration. Okay, fine.